Good morning, good afternoon, good evening. This is Professor Sistrunk, and I'm reaching out to my routing and switching students. Okay, this is the first of many video logs that I will be sending you. And I just want you to understand, all of the video logs will be placed inside of the discussion questions. That way, when you go do your discussion question for the week, woohoo, your video log is sitting right there in front of you. And understand, every week you will have a discussion question. And for those of you who don't remember, you got until Wednesday or whatever class you in. Please look at the syllabus so you'll know when you have to get that initial discussion in. Now this week, of course, this is the first week of class. So I'm going to have a little latitude with students because I know you're trying to get engaged. You're trying to figure out what to do. And you may miss that Wednesday or you may miss the whatever day it is. Remember, I'm dealing with two different classes that's dealing with routing and switching. So just know this is the first week. Another important announcement is that September the 8th, if you haven't did any work by September the 8th, I must drop you from the class. And that's only because it's not my choice. The college mandates that happen. So make sure you get in there and do your work. And you can just do a discussion question to make sure you're on point. Okay, with that being said, I want to talk about a couple of emails that I received from students. The first email, a student emailed me. He said, "Hey, Professor Sistrunk, make sure I don't get dropped. I'm getting on a plane going somewhere." And I'm like, I'm not finna drop anyone. But I understand the urgency that the student was trying to stress. He or she wanted to make sure that they didn't get dropped from the class. Students, I want you to understand, you do not have to show up to the lectures. That's totally on you. What I do in the lectures, when we meet in the Zoom meetings, is I basically go over labs. What I like to do is to be engaging. So I'll pull up a lab and I'll say, "Hey, check it out. James Dean," if I had a James Dean in my class, "what do you think about this? How would you do this? What is the understanding of this?" So I'm gonna be picking at you as you travel through the classes to see that you know how to do the configurations. So the Zoom meetings is not about lecturing, it's about you demonstrating your skill set to show me, "Hey, Professor, I know how to do this and I know how to do that." That's what these classes are about. I am going to send you what I call a video log lecture. This here, I'm going to send you this prior to class. You review it, and then when you get in class, you know all the concepts and things that I'm expecting. So take a look at this. Step back for a minute. Sit back, relax. You would have read the chapter, and I said been on, so don't trip on me. You would have read the chapter. You would have looked at a video log. You would have completed either labs or packet traces. So when you come into the class, you super souped up. You know what to do. You know how to configure routers and switches. So that gives us the opportunity to go deep off in it. Our class meets from 6 to 9. I'm opening the session up from 5 to 9:45. So we can be in the class. So I'll be in there just sitting, just chilling. All you got to do is just log in. And some students come in and then they leave out. They come in for a minute, they see we doing labs and packet traces and they engage. And they say, "Oh, I got this stuff," and they leave out. Some students don't show up because, "Hey, I'm doing my work." As long as you're doing your work and you're getting things done, then you really don't have to show up because you pretty much already know the stuff. But what you don't understand, we'll walk through in this particular thing. Some students want to bring up certain things as long as they're about that particular chapter, that particular lab, or what's going on, we focus on that. And then you get a lot of extra information. I may tell you about, "Hey, go look at this particular YouTuber, because this YouTuber is breaking down a career as a network administrator." Or I may tell you to go look at this, or focus on that so you can get a more better picture of what a networking administrator do. So first and foremost, one, you don't have to show up. As long as you do your work and you look at the video logs, you're okay. Two, if you show up, you must turn on your camera. I need to see your face because it's accountability. I talked to students and I already told them what happened in prior semesters when Zoom started getting hacked. So first and foremost, turn on your camera. Three, I'm going to send you a different Zoom connection because I'm separating the classes out now. I did my initial introduction to everybody. Now I'm separating the classes out to where you can have your own Zoom portal. And that's pretty much it. So another student emailed me and said, "Oh, Professor, I'm so busy and I don't know what to do." In those particular cases, if you are at a rush and life is life, you guys are going through a lot of stuff in this world. So reach out to me, text me, call me and say, "Hey, Professor, can I, get a moment of your time?" I'm here for you. So utilize me as much as you possibly can. That's what I'm here for. So with that being said, you know the course to follow now going through this semester. And trust me, you're going to enjoy this. But it's one thing I can't control about you. You have to bring it down a notch. Calm down. We in the first week. Don't allow yourself to be overwhelmed. And if you are overwhelmed and you feel overwhelmed, reach out to me. That's my job, to take all the mess and clean it up and make sure we're on the right path. With that being said, you got it now, and hopefully you'll follow it. I always know it's some students that say, "Yeah, Professor, you saying that, but in reality, it's a lot going on." But you can, and just know this: managers of IT departments hire people who can deal with the chaos and put the chaos in order. And that's what we want you to do. We want you to learn how to be able to do your job, but deal with the chaos, because chaos is always there. It will never go anywhere, but it's how you approach the chaos. I never approach things in a panic because I know that, guess what? This too soon shall pass. That's been my motto for everything in my life. Whatever come my way, this too soon shall pass. Okay, now you got Professor Sister on philosophy of life. Let's move forward. Routing concepts. We finna get to the thick of things. Okay, so with routing concepts in this particular chapter, I want you to understand at a CCNA level, the primary thought you should have in your mind is that I am coming in as a technician. I am coming in as a troubleshooter. I am not coming in to rebuild the network. I am not coming in to design a network. If you're blessed to do that as a CCNA, please call me up. I want to jump on that boat. But you just, in this particular chapter, you want to get that initial configuration down. As you see right here, you want to be able to describe the primary functions of what a router does. Pretty much the different parts of a router. You want to understand how to connect devices, whether they are small office or a network, a bigger network. You want to be able to configure settings on a router, okay? Basic, you heard me say in the last class, have your basic configuration together. And I'm going to introduce you to that. Remember, I told you, I'm going to show you that basic configuration. Then you want to be able to verify connectivity. The biggest problem that I have with a student understanding their position as a CCNA is this. You're a troubleshooter. You should be able to go in there and see things and be able to correct them. Now, that doesn't mean that they're going to give you with your privileges. Remember, every employee in a company, especially in the IT department, has a certain level of privileges, meaning you may be at a level 1 and have level 1 privileges. What do that really mean, Professor? Well, it means this. You may confine the problem, but you have to escalate it up to the professional who will correct the problem. Your job, find it, tell us what's going on, escalate it up to the next person. Now, you may be working in a small company that allow you to find problems, fix problems, but when we on a network, we want to separate privileges out so the people who finding the problem are not the people who fix the problem. We want to say, we want you to take that ticket, and that's what we call them, a ticket, and escalate it up to the next person who is up on a professional level, who have more credentials than you. And when I say credentials, I'm talking about more skill sets to fix the problem, and then we'll go ahead and fix it. But most importantly, this is why this is really important. We want you to be able to explain these problems. Tell us in your notes what is really going on and what did you find. But the most important tools that you will use are what we call show commands. So make sure at the end of this chapter, you can memorize the different show commands. Routing operations. Remember, you're going to hear me use the word configure, configure, configure. That's the operations of the routing. Understanding a routing table, understanding how routers are built, how routing tables are built. But listen to this, though. You want to get an understanding of it. You want to be able to explain it. You don't want to be hardcore right now in your career, because this is a process of elevation through being a network. You're going to start as a CCNA, then you're going to move to a CCNP, and you may go on and on and on. So don't try to put all your energy and knowledge into knowing every little detail of it. It's a process. When you get in the field, you'll see the process. Some of you going to go into cyber ops or go into some security stuff. So you just want to know the basic stuff. So for you, just be able to understand it and explain it to somebody. And one way I tell people, if you got a little brother, sister, or children at home, once you understand something, explain it to them and see if they understand it. And then I got it. I understand it. I understand it. I have it. Okay, moving on. I know you're getting tired of me. Professor, move on. Okay, I'm going. Okay, router initiation configuration. So what is a router? A network device that forwards traffic depending on the destination IP address. Understand that concept. The destination IP address. Okay, that's what routers do. So if you can see in these 4 basic steps, and by the way, I took this from Google, so I like getting information from them. So for disclaimer reasons, I got it from Google. Okay, I took a Google class, and in the process of taking Google class, I like to do cloud computing, so I went through that process. But anyway, so receive data packets. The router receives the packet, examines the destination IP address, and looks up an IP address, destination IP address on the routing table. So get the concept. If you get this concept, you got the whole chapter. You stop, you move on, you go to somewhere else. Don't do that though. Finish the chapter. Finish reading it. Please read the chapter. Some students don't want to read the chapter. How can you work in the IT industry and you haven't even read the book? But anyway, moving forward. So to understand this concept, the router receives the packet. It strips off these different parts of the packet and it examines it. It examines it looking at the destination IP address. And then it goes to its table and it says, hey, table, do you have this IP address? If it does, boom, it shoots it out, forwards it to it. If it doesn't, it goes to the next router and says, hey, who has this? So that's what the router does. That's the basic concept. Now, I just gave it to you in the most basic way a person can give it to you. But let me tell you something. There are volumes and volumes of books written on this concept. That's why, as a CCNA, I just want you to get this one concept down. So if an IT manager ever asks you, so how do basic routing happen? You can just say to IT manager, plain and simple. Router receives a packet. It looks at the destination IP address. It goes to its routing table and it sends it where it needs to go. based on the routing table. Boom, that's it. But understand, there are people writing volumes and volumes of books on how this concept is. So don't try to get that deep. You'll see CNA. Don't try to go that deep. Moving forward. Okay, now if you want to understand the different characteristics of a network, we got a router, but we got a network. Remember, in your first book, you had to know these concepts. And if you didn't read it, make sure you read it now in this book. The topology, the speed, the cost, the security, the availability, the scalability, and the reliability. All these plays a significant part in what we call the network or cyber, the cloud space and all that. This is what sets the foundation of how this process works. You learned in your previous book that you had a topology that consists of a physical topology and a logical topology. You know, when it comes to the physical topology, it is anything that you can touch, feel, see, and move. That's the physical topology. You know, when it comes to the logical topology, you don't want anyone to touch it, to feel it, to move it, or to have it, because that should be under top security. Your physical topology means that the devices, whether they end devices or intermediate devices in your company, should be locked up behind a door where no one can get it. But your logical topology lays out your IP address schema. It lays out the entire network in your company. And if a hacker gets that, he owns, or she, because there are women hackers out there, ladies. Yeah, I know you can hack too. He or she can own your company. So the physical part you can solve simple. Somebody get to that, you shut it down, it's good. But if they get the logical part, these are your IP address, this is your network schema, this is all these things that can destroy your company. So you want to lock that up. You see where it says here, the physical topology, arrangement of cables, devices. These are all the physical things, but the logical topology describes the path over which data is transferred. I want to hack you. I want to get that data, and I got you. So that's your topology right there. Now, the speed is based in metrics. So we're going to talk a little bit about that, but you just got to know the count, the metric count that we use when it comes to speed. But what's important, let's go back. I'm going to say this several times. Just understand it. Just understand it. Don't write a book on it. Just get a basic understanding. You want to be able to understand it. Okay, so when we talk about cost, general expense for purchasing of network components, security. You always going to hear me say that 3 times. Everything should be secure. The availability means, okay, you got the best network in the world. It's the most secure network in the world. But if it's in the basement, locked in a safe, listen to this. You got a computer. You can make it the most secure computer in the world. You can take that computer. You can put it in a basement. You can lock it in a safe. You can have pit bull dogs out front of this thing. You can have You can have a room with all type of locks on it. You can have guards standing out. It can be 60 feet underground. But the thing is it available for people to use? So you got to make sure you have your network where it's available. Securing it to the max and no one can use it, it really has no valid. It's really not worth anything. Okay, moving on. Scalability means how do you grow your network? If you ever take what I call a cloud computing class with me, you get to scale your network up really fast. But if you on on-premise network, on-premise means you at your business, your company, it's hard to scale your network up. So you got to think of the future planning. Okay. So scaling it up means, do I need more routers? Do I need more switches? Do I need more computers? Scaling it up. You got to make sure your network can scale up. Reliability, is your network dependable? Are you getting the right information to the right people? You know what reliability is. Come on, stop it. Okay. moving forward. So this is a basic way routing is. Connects one network to another. And pretty much we already know this. If you look up in here, you see that this router goes into the cloud. It may go here, go here. It's just basically making sure networks connect. And that's really, really important. Okay. Making sure that they connect. Determine the best route. That's the routing protocol. It determines the best route. Response to routing traffic. If there's any problem, your router, your network should be able to correct itself. Routers talk to other routers. Routers are always communicating to routers. It's more traffic on the network with routers communicating with routers than it is when people sending information through the network. Okay, moving right along. And routing tables. And you're going to get a chance to understand a routing table and what routing table is about. But just keep it fundamental. Just understand what a router table is and the different sections of a routing table to make sure you understand this. Okay, so we're 21 minutes into this. Stop right here. Take a little break. Take 5. So with that being said, you took a break. You're back now. I'm going to go ahead into the next thing. Routers are computers. This is a basic picture of what a router looks like. Now, I want to say this. These are ports, okay? These are ports. Know your ports. Know why you're configuring some. And most importantly, most professors probably haven't told you this, but this I will stand on. If it's a port on your router that's open and you are not using it, you should be closing that port. And that's ports with any devices, but especially on your router. If it's not a port that you're using, it should be shut down on your router, plain and simple. So if I come and put a new card in here and it has probably 2 or 3 ports connected to that card, if I'm only using one, the other 2 should be in shutdown mode. Remember that. A lot of professors don't tell you guys that, but that's highly important to understand. Shut your ports down if you're not using them. Moving forward. Okay, so this is the same concept of routers interconnecting. You understand the cloud. You understand routers interconnect all over the world and things like that. So we're going to move forward on this because this is something you can read. LAN, you pretty much got LANs down. You pretty much got WANs. For those of you who don't really get the concept of LANs, I'm going to give it to you, or WANs, I'm going to give it to you like this. A LAN is simply this. Something that's within your business, okay? It is a switch. When you think of LAN, think of switch. When you think of switch, think of LAN. It is not a router. It's not other devices. It's the switch. The switch is the workhorse of the company, okay? That's a LAN. And the last thing is you do not go outside of your company. The switches keep everything inside of the company working. When you think of WANs, the WAN is the router. When you think of WAN, you think of router. When you think of router, you think of WAN. The router gives you access to the world. It goes outside of your company. You got that concept? You understand LANs, you understand WANs. You can take that into an interview and kill it. Crush the interview. Okay, moving forward. I know you picked it up in the first class though, but just in case that's something you missed. Routers choose the best path. And that's what it means. The best path is just simply how a router functions. So when a router receives something or is sending something, it want to make sure the best path to get that particular information, or as we call it, packets, to the place that it is. You really don't have to have a discussion about it, but you just need to know that when a packet comes in or a packet is going out, let's say, for instance, I email somebody in Japan. I don't know what path that router will use. I know I email somebody in Japan and the router is going to choose the best path based on how the network is set up. And we're not just talking about your network. Once it leaves outside of your network, it's other routers out there all around the world, and they choosing how to get that information where it needs to be, okay? So routers choose the best path, and one router communicates to another router, and another router communicates, and they always talking to each other and say, hey, send it here, send it here. They don't really say that. I mean, but they using the best path. And the paths is normally based on what type of routing protocol are you using. Are you using EAGR? Are you using OSPF? Are you using RIP? If you're using RIP, you're in trouble because RIP is dead. You shouldn't be using RIP. But you see here, right here, you got EAGR or EIGRP. You got OSPF. You got, I think RIP protocol still in here. And when you get in the cloud, you're using IS or ISIS. You know, people got their way of saying it. But the router chooses the best path to get that information from one location to the next location. So read through this section and just know you want to understand what do they mean when they say best path, how one thing gets from one place. But sometimes I have to stop students because they want to go so deep into it. In an interview, all the IT manager is going to ask you, so how do a router gets information from one place to the next place? And it says, depending on the routing protocol, it chooses the best path. That's how it gets from one location to the next. There you go. We're done. We're moving forward. Use that in your interview. If they go a little more deeper, what do you mean about the best path? Then you go in and talk about some of this here, but they not you. This here diagram is important. It will be on your certification test. They want to know, do you have an understanding of how information flow? And they try to trick you on this. So they may ask you a question, do you understand how this information get from one location to another location? But you got to make sure, is it talking about a router? Is it talking about a switch? And if it's talking about a router, you know to go to the destination IP address. Okay, devices need the following information for network access: IP address, subnet mask, and default gateway. So you want it. That will be a test that you see on your Cisco certification test. Just make sure you can understand how to follow the path. And if the question is about routers deal with the destination IP address. It says down here the default gateway is the device that routes traffic from one local network to devices on remote networks, such as devices on the internet. That means the default gateway is the gateway that sends stuff outside of your house. Routers are also usually configured with their own default gateway. And you know that. You already know that. I think you know that. You know it. Okay. We're not going to talk about enabling hosts because you already know what a static IP address and a dynamic IP address is. You went through the first class. That was hit heavily in there. So we're going to move forward on that. Basic configuration, enable an IP address on a switch. Now, you know that a switch has a management port. That port is how you configure the switch, especially if you remote. So you want to make sure that you have interface VLAN 1. And in the industry, we don't call it interface VLAN 1. We give it a number that no one would know. This is just for the class. And then you configure that switch in a no shutdown. So when you need to remotely connect to that switch, we're not talking about walking up to the switch and plugging an access cord in and configuring it right there. We talking about when you remotely away, you need to get to that management port so you can manage your router and remotely do it. Okay, so that's important right there for switches. So what that really means is we put an IP address on there. So if I'm in Europe and we got a switch having a problem in America, I can just simply remote in and correct the problem. Woohoo! You got it. You understand it. But you covered that in the first class. That's why I'm passing this. Most of this stuff you already got in the first class. So right now we got, you hear me talking about this all the time. Basic, configure basic routing settings. You should have a basic configuration already built out in your mind and know what it is. I'm going to give you a screenshot of a basic configuration. I'm going to pull that in. Here is a basic configuration right here. You should know automatically off the top of your head. Enable, configure terminal, give it a host name, no IP domain lookup. Now that no IP domain lookup means If you don't have a domain set up on your network, which if you got a network, of course you have a domain IP. But if you're working on a isolated router and you configuring it, you want to have that in it so it just don't jump around. But then you got secret passwords. Now we got more complicated secret passwords out there and how things is. In truth, when you come in an organization and they give you your privileges, meaning your credentials to log in, you won't see no line console secret password and all that stuff. You won't really see that because we have better ways of doing this. This is just to get you started off if you're doing it, doing a configuration, okay? And you should be able to pull that up. And this is how it should be. I want you to start pulling up Notepad and typing in your configuration just like I did. I'm going to pull this back over. Just like I did. You can take this configuration right here, copy it. I'm going to copy it. And then you can drop this configuration right onto a router and switch. So I'm going to pull this over here. This is my Cisco packet tracer. Woohoo! You are messing with Cisco packet tracer. You're getting good and better and better and better. I don't want to hear, Professor, I need the real stuff. I got packet tracer. So I can take this router and drop it right here. Okay, give it a minute to initialize itself. That means to set up. Let me show you what the setup look like. Let's see if it can do it. So it's initializing the router just like a real router would be. When you turn it on, it goes through its initialization phase. You probably know it in terms of the boot process, because you hear about when it comes to computers, we call it the boot process. But when it comes to routers, we just say the initialization phase. We give it a nice little term. It's the same thing. Now, I'm here at the router console. I'm just going to copy and paste this in, and there it is. The configuration is set up. I got passwords on there, Cisco passwords on there, and it's set up. So if I exit out now, this is a basic configuration. And I just did Notepad and put it together. So I'm exiting out of here. Okay, what happened? The first password, it came up. So I'm going to go ahead and type in my Cisco password. Hopefully I do it right. I did it wrong. Let's do it again. Okay, now I'm here at the router prompt. I'm going to go ahead and enable. And it asks for another password. I kept the passwords the same thing. Now I'm in the router. I can do my work. So get used to creating a basic configuration and put it in your mind so you can remember it. Okay, lock it in. There you go. I can delete this now. I'll save it. Maybe I'll use it again. Okay, so that's the basic configuration. And I'm going to ask you questions. I'm going to say, okay, Peter Paul. I'm just making up days. What is the command I need to type in here? Where are we at? Oh, okay, I see right here we at line VTY. What is line VTY? Why am I doing something with line VTY? Why am I putting the service password encryption in? See, these are things I'm gonna ask you while we building our labs when we meet. Remember, you don't have to come into the Zoom sessions if you got this and you know this. Some of you are progressive. Some of you pretty much got this down. Hey, professor, give me the book, give me the access. I'm rolling, I'm going. But some of you may need some extra, and that's what I'm here for. But I do my extra by breaking it down, going through it step by step. Okay, so now we done did a basic configuration. You should know how in your basic configuration how to put in interface Giga Ethernet 0.0, how to set up, how to configure access a port. You should know how to do that. You should know how to put no shutdown in there so you can make sure that it is secure. These are basic things you should know going forward in this class. And if you don't know it, don't panic, don't worry. Just simply go back and review the material in your first book and just come on and let's move forward. There it is. No muss. Okay. And this is a basic configuration of IPv6. And people understand all you doing with IPv6 is saying IPv6 enable. That's what you're doing. You put an IP address on it. It's the same concept. You just add some extra. You can see it right here. This is a serial port that we configuring. We gave it a description. And then we said IPv6 address, and we gave it the IPv6 address. Another thing about this clock rate stuff, they put it in there, but understand this: you will not be going out there typing in no clock rate in no configuration of no. You have to be the network architect to be doing that stuff. And every company do things their way, but in truth, you will not be doing that. CCNAs don't get that privilege, and they won't be setting that. We got up moving forward. Now we get to the show commands. You should know each one of these show commands. So I'm gonna ask you when you show up to class, when we doing something, what command would you use to look at that interface? What command would you use to find this out? And you should say show IP interface brief, show IP route. Now, starting off, yeah, it gets a little bit, you can say, I really don't got them down. But you need the show commands to be able to troubleshoot problems. I stress this a lot. Know your show commands. And you can simply read the description of what they do, display interface information on packet flow, etc., etc. But just know your show commands, because you want to make sure you use the right show command to solve a problem. And as you see in the display right here, it's allowing you to see what the person is looking for and what they're trying to figure out. And trust me, after a while, you'll instantly know what a problem is in the show. It doesn't take 2 or 5 years to figure it out. Once you start using show commands, you just instantly get good at it. So moving routing decisions, the same thing. The primary function of a router is to determine the best path. We done talked about this several times going through here. Okay, moving right on. Okay, and it talks about, now here's the different routing protocols. Remember these protocols: RIP, OSPF, EAGR. I say EAGR or EIGP. Only one that's really concerning to you, one that you really have to focus on, the one that you should know in and out, is OSPF. In the next Cisco courses that's rolling out, we dealing with OSPF. I spoke about this for many, many years. Why are we teaching people RIP? Why are we teaching people EAGR? Oh, they need to know it. Okay, let's stop it. You need to know OSPF, because that is the, okay. And now this chart is important. You should know the administrative distance of all of these, even though we're not using most of them. But as you can see, connected is directly connected. That's the lowest cost, means that's the better path to travel. And that's 0. Static, that means you put a static IP address on your router, and that's better. EIGRP, or as I say, EAGR, that's a 5. Internal BGP, that is inside of the cloud, so you don't have to worry about that for the class. Just know that it's a 20. External EIGRP is a 90, so you're gonna see a lot of that in your labs and stuff, but hopefully never in the real world. And EIGRP, that's a derivative of EIGRP. These here is not existing right now. But OSPF, big dog, is out there. You need to know that 110 is, or as I say, ISIS. I say ISIS. That's out there. That's for the internet. RIP. Okay, you get the point. Just know the numbering scheme. So just make sure you can remember the numbering scheme. But most important, make sure you can focus on OSPF. Okay. I know a lot of teachers teach all these different protocols, and you have all these protocols in your head. But at the end of the day, when you come out there, it's going to be OSPF. Okay. OSPF. Lock it in. Lock and load. So if you want to spend some extra time reading, make sure you read up on that. I mean, these guys amaze me. Routing operations, understanding the routing table. By understanding the routing table simply means how the router forwards information. Yes, you're gonna hear a lot about the next hop. The router decides what's the next hop based on how the network is set up, based on when the information is going out there. And it takes the path of least resistance. Now, I used to do this little diagram of a dial-up phone, a DSL, cable, satellite, and just show how it may travel through various networks. I don't have to do that no more because we're doing OSPF, and you just know it's going to take the best path to get there. And the best path can be fast, slow. It's using the best path to get that packet to its destination. That's all you need to know. Right here it says show running configuration. You know, show running configuration. I don't need to go deep in there. It's just going to basically lay out the configuration that you have. Understand local route interface, direct connected interface, static route. These are important to remember. Make sure you understand them. And that's just direct. It's what it says it is. Direct, a directly connected interface. It means that particular router is directly connected to your network. So that it is. It's simple. Don't make it complicated. You saw the show command there too. Now this here actually explains that. It says the D right here, identify how the network was learned by the router. Meaning, how did the router discover that particular network? You see the little pink here, identify the destination network. So it has the destination network right there, okay? And so on and so forth. Read through it, understand it, and know how it travels. But don't write books on it. It's just basically to get an understanding. And as you can see right here, when you see that 90, you know what routing protocol is being used. And if we come down here, it says identify the administrative distance, trustworthiness of the routing source. So it's at a 90, and you know what protocol that's being used. And here's the metrics and stuff broken down right here. Okay, timestamp, etc., etc. Okay, moving on. So at this point, if it's anything that you don't think you're getting, you can ask me a question about when we get into the class. But we're going to be working through labs, so you actually see. I mean, you may not see us doing the actual protocol, but you'll understand it. Here go another show IP route, which we just got through looking through this whole table and seeing all of this information on a particular router. Directly connected interface, the D that you saw, is showing you what the directly connected interface looks like. I mean, I said D, but it's really C right here, okay? Okay, static routes. It breaks down static routes. You know how to set up a static route. No, outside of your company, you don't set up a static route. You set a static route up on your particular routers, okay? Because some people think, I'm going to go static route everywhere. No, you're not. No, you're not. IP route, and that's hop. It has here the IP route. The default static route is similar to a default gateway on a PC. The default static route specifies the exit point to use when routing table does not have a path. So what they mean by that, if the routing table can't find a path, it'll go to the default static route to be able to forward that packet where it needs to go. I know you're saying, Professor, you're saying that over and over again. Yes, I am. Dynamic route protocols are used by routers to share information. Like I said early on, routers consistently talk to each other so they'll know what's the best path to send a packet. And they doing this consistently. It's something that's just built in, okay? Now we have IPv4 routing protocols, and here go the protocols right here. Cisco routers support a variety of IPv4 protocols. But you know, you got many different routing companies out there. Cisco just happens to be one of the biggest ones out there, but it's many of them out there, okay? And this is EAGR, OSPF, ISIS, RIP. Please don't say RIP. RIP is... Okay, we are back. And right now in this particular session, we are going to take a look at a packet tracer. Now, you're going to notice that after every lecture, I'm either going to do a packet tracer or a lab. I'm going to take the packet tracer or lab and put it at the end, or I'm going to put it at the beginning, because I want to basically make sure I mix it up. Sometimes this gets boring, especially when you're doing video log lectures. It can get real long, it can get boring, and yes, I know, I'm with you. I'm not off too. When I used to be in the classroom lecturing a lot, I just like look back there and I see some students just almost gone. It's a dry, and sometimes it's boring, but it's important. and you just got to just stay motivated to get through it. This one here, we're investigating directly connected routes. So in here, you just want to be able to use your show command to see these particular routes that you'll be going through. And it gives you the information to utilize. So this won't be a lab where it won't lay out what you need to do. And you just answer these questions. And once you answer the questions, you'll upload the questions as well as the packet tracer, the PKZ file. You'll upload both of them so I can review your work, okay? And give you the maximum amount of points that you can get in it. So I'm gonna shrink that down because I got my little notes over here. And what it wants me to do is first go to R1, which is router 1, and open that up. Now you see here, you have your router, you got your plates on, locking it out, you got some more serial ports there. Make sure you start understanding these routers, and also you see that it's turned on. So I'm gonna go to CLI, and then this gives me the opportunity to see that the router has initialized itself and it's up and ready to go. You could take some time to look through here just to see what the initialization phase is all about. But with that being said, you see that we are ready to go. So the first one is Cisco. I'm gonna type that in, and that allows me to get to the next level. And I'm gonna go enable, and enable wants another password, which is class, and now I'm in. Now it wants me to show an IP route, and I'm not going to do shorthand because I know some of you guys are getting used to the shorthand way of things being done. I'm gonna just start out by spelling everything out, but when I'm in the real world, I do everything shorthand. But I know in this particular class, I'm just going to spell out. So we're saying show IP routes. We want to see the routes that R1 has, and we want to see where they are. So let's take a look at it. So now here is R1. Okay, and as you can see the routes on R1. So it has approximately, if we look at the interfaces that connects to it, you see Giga 1 right here, you see Giga 0, and then you see a serial port going over there. And can I see those? You won't see it. You won't see the ports actually connected to it, but you will see them right here. You will see it spells it out Giga 0/1, and you see that right there. See, so that's that IP address, okay? And then you see Giga/1 here. And then you can see that IP address is connected too. So you get a chance to see the IP address is connected to it. Now, what the questioning is asking you is to saying, do we got a direct connected route and so on and forth. And you want to make sure that you do have a connected route, and you see these local routes, and then you see the connected route. So you even see the serial ports connected to this route. So now this router is talking to this router here. That means one network is talking to another network. And I want you to visualize this. This is not in the same company. This is going from one network to an entirely different network. So these are two networks here. Now in the company, we do have routers connected to routers, but this here is representing two separate networks. Okay, so we had a 172.31.20 and so on and so on, so on. So it's all laid out right there. And then we see that we have the serial connections. They are up and running, and we see everything working there fine. So that's pretty much what this lab was about. It has a lot of other things that it wanted you to do. It wanted you to go to the PC and verify PC addressing and test connectivity. That there I'm not going to do because you can actually go do that yourself. I mean, I'm not going to complete the whole lab for you. And then the very last thing, investigate directly connected routes using IPv6. Just so you know, it's the same way on R1. You type in route IPv6. So to nip this down and not make this a long drawing out, this is how you do these particulars, and you can do it the same way. People, it's just replicating one thing that you learn and then continually do it over and over again. That's what it's about. You don't have to create no magic bullet or come up with anything. You simply use your show commands to find out what problems you have or to get information about your routers and your switches. So if you can do this with one router, you can do this with multiple routers and you can read the information. And that's what makes it simple and easy. And that's why I like it. But if you don't read the material and you don't dive deep into the material, what will happen is this: as we proceed on, you won't know how to do this simple thing. Okay, so this is Professor Sistrom. We are now closing out this chapter 1. I want you to get ready for chapter 2. That's also coming. And remember, review your logs. What I'm going to do now is I'm going to send this to you. And I'm also, let me bring this up. So what I'm about to do now is I'm going to send this to you. And I'm also going to put a question in here. I'm going to put a question in chapter 2 because we already got the first discussion question. And that was just basically tell me about yourself. Hey, I want to get to know you. But I'm going to send this out to you now. And then we're going to get ready for chapter 2 and send that out to you. And I'm going to keep rolling them out, in the discussion question section. So now in the classroom, if you decide to show up, remember, I know people jumping on planes, people going through life situations. If you don't make it, it's okay. Just continue to do your work. And if you need some assistance or help with anything, just reach out to me. This is Professor Sistrom, and I hope you enjoyed this session, even though I knew it was boring, but still, have fun. I'll see you hopefully in class and get prepared for the next video log lecture.